When we're doing dilution calculations, you want to use the dilution equation, which is given here as C1V1 equals C2V2. When you do this, keep in mind what each variable means. C1 is the initial concentration. Usually this is your stock solution that you're starting with. V1 is the volume or amount of stock solution that you use, the amount that you're starting with that you're going to dilute. C2 is your diluted concentration, the new concentration of your solution after you've added water or additional solvent to it. And V2 is the total volume of the solution after the dilution. And that's a key point. The volume is the total volume after. So usually when you're doing V2 is going to be the amount of stock solution that you started with plus the volume of water or solvent that you added. So let's do a practice calculation. We have a student that needs to perform a series of dilutions of stock solution to make standards, which is very similar to what students do in Beer's Law lab. If the concentration of the stock solution is 2.54 micrograms per milliliter, we want to calculate the concentrations of diluted solutions. So we want to get the new concentrations, or C2, of all of the dilutions that we make for our standards for this lab. Now, first let's go through and write out what we're given and what we want to get. So we're given the initial concentration. So our C1 is 2.54 micrograms per milliliter. We are looking for C2. We want to know the diluted concentration. Our V1, well, we're going to have a series of V1s. That's the stock solution given in the table. So V1, we're going to get from the table. And V2, that's going to be our final volume, which comes from the stock solution plus the amount of solvent, in this case water, that we add to it. So for this particular set of standards, you're going to notice a trend. Your stock solution plus your water that you dilute it with, 15 milliliters plus 5 milliliters, that's going to give you final volume, or V2, of 20 milliliters. And again, the 10 milliliters of stock solution with 10 milliliters of water, again, that's going to give us a final V2 volume of 20 milliliters. And the third dilution we're going to do of 5 milliliters, adding to that 5 milliliters of stock solution, add to that 5 milliliters of water. You guessed it, 20 milliliters of your standard. So what you'll notice a lot of times when you do these dilution equations, if you're making a series of standards like we are here, your V2 will most likely be a constant value. In this case, it's 20 milliliters. Remember, it comes from the stock volume plus the volume of solvent that you add, additional solvent. So keep that in mind anytime you are doing one of these problems. All right. So again, when we see that we're doing a dilution, if you see dilution very often, you want to just go and get the dilution equation, which again is C1V1 equals C2V2. We want C2, so we want to rearrange the variables in this equation so we get some sort of new equation that gives us C2 equals something. So for us to have C2 by itself, we need to get rid of V2. Well, because C2 is multiplied by V2, we undo multiplication by division. So we're going to divide by V2. We get V2 over V2, which reduces out to 1, or as we say, cancels out. But since this is an equation, what you do to one side, you have to do to both. So we're going to divide the other side by V2. So now we have a new equation that says C2 is equal to C1V1 divided by V2. And now, to solve for these three new concentrations, all we have to do is plug in the variables, or plug in the amounts that correspond with the variables. So again, C1 for each time is going to be that same stock solution, that 2.54 micrograms per milliliter. And we're going to, the V2 we see each time will also be 20 milliliters. So the only thing we have to vary to get these 3 new C2s, the new concentrations for the 3 different dilutions, is the V1s from the table. So let's start with the first amount of stock solution we're going to use, which is 15 milliliters. All right, and now you can just see that when you set this up, you want to do your unit analysis. You end up with milliliters over milliliters. That goes to 1 or reduces to 1 or cancels out. So we're left nicely with just the units of micrograms per milliliter, which is good because that's a unit of concentration. So we know we set everything up properly. Now you can plug the numbers into your calculator, and if you do that, you should end up with 1.905. We'll round that to 1.91 micrograms per milliliter. That is the C2 for 15 milliliters of stock solution. The new C2 is 1.91 micrograms per milliliter. Now to solve for the other 2 concentrations, we don't have to change anything. All we have to do, well, we don't have to change most things. We're just going to change our V1 from the table. So again, V1, let me do it this way. V1 right here is the only thing that we have to change that's going to come from the table right here. So now we're going to put in, for the second dilution, we're going to put in 10 milliliters. And again, my milliliters over milliliters should reduce out. I'm left with units of micrograms per milliliter. And that would be 1.27 micrograms per milliliter. So my C2 for 10 milliliters is going to be 1.27 micrograms per milliliter. And lastly, for that third dilution, all I'm going to do is just switch out that 1 value, the V1. That's the only thing that's going to change. This is going to now be 5 milliliters. Milliliters over milliliters again will reduce out to 1 or cancel out. And if we plug that in our calculator, we should get 0.635 micrograms per milliliter. And so that would be the C2 for beginning with a stock solution of 5 milliliters. So you can see using the dilution equation is really straightforward. Just make sure that you're clear on what each variable means and be clear with your work so you don't accidentally switch anything out.